Wärtsilä Sulzer RTA96C. This engine looks like it was built for a machine from another planet. With 14 cylinders, it could produce around 80 megawatts of power, enough to propel some of the largest container ships of its era. But here's the crazy part. It doesn't need to spin incredibly fast to do it. Instead, its massive cylinders operate at low speeds while producing enormous amounts of torque directly to the propeller shaft. Think of it as trading speed for sheer mechanical force. Each piston travels through a gigantic cylinder, turning the pressure created by combustion into movement. The pistons, connecting rods, turbochargers, and other components are enormous too. And this engine was designed to keep working continuously across thousands of miles of ocean. But that's not even the most impressive part. MAN B&W 12K98MC. This engine takes the idea of big to another level. Built for the era of massive container ships, it uses a two-stroke design that can produce enormous torque while turning at surprisingly low speeds. And that sounds strange at first, because most people imagine more power automatically means more revolutions. But marine engines work differently. Instead of spinning extremely fast, this giant slowly pushes huge amounts of force through the crankshaft, which connects directly to the ship's propeller system. The result is a machine capable of moving an enormous vessel across an entire ocean without needing a traditional transmission like the one found in a car. But there's an even crazier detail. Its low-speed operation is actually one of the reasons these engines can be so efficient. MAN B&W 11G95 MEC. This engine represents a major step forward in the evolution of massive marine propulsion. At first glance, it looks like an enormous industrial machine, but its real advantage is hidden inside the way it controls combustion. Unlike the giant mechanical engines of previous generations, the 11G95 MEC uses electronically controlled fuel injection to precisely manage when and how fuel enters each cylinder. That might sound like a small technical improvement, but on an engine this enormous, tiny adjustments can have a huge effect. The system can optimize combustion across different operating conditions, helping the engine produce tremendous power while reducing wasted fuel. And remember what this engine is moving: a container ship carrying thousands of tons of cargo across entire oceans. Every stroke of its massive pistons contributes to turning a gigantic propeller, while sensors and electronic controls constantly monitor the engine's operation. The crazy part is that this enormous machine combines brute mechanical force with computer-controlled precision. But even this level of engineering would eventually be pushed further. This engine is so massive that it can push a ship across entire oceans without stopping for weeks. But that's only the beginning, because the real surprise is how a machine this huge can operate almost like a precision instrument. The WinGD X92 is a modern low-speed marine engine created for some of the world's largest container ships. Unlike regular engines that constantly speed up and slow down, this giant is designed to run at extremely low revolutions while producing enormous torque. The secret is efficiency. Every movement inside the engine is carefully controlled to waste as little energy as possible. It can keep thousands of tons of cargo moving across thousands of miles of ocean, day after day. But the craziest part is that this engine is built to survive conditions that would destroy ordinary machines. It has to handle extreme pressure, non-stop operation, and massive forces while remaining reliable far away from land. And this is where modern ship engines become truly impressive. Most people think the biggest engines are simply the most powerful ones, but this machine became famous for something different: intelligence. The Wärtsilä 31 proves that a smaller engine can still be revolutionary when efficiency is the main goal. Designed for marine applications, this engine focuses on extracting more performance while using fuel more effectively. Its technology allows ships to reduce consumption without sacrificing the power needed for demanding operations. Inside, advanced systems monitor and adjust performance to keep the engine running at its best. That means less wasted energy and better results during long journeys. But the surprising detail is its flexibility. Designed for marine applications, this engine focuses on extracting more performance while using fuel more effectively. Its technology allows ships to reduce consumption without sacrificing the power needed for demanding operations. Inside, advanced systems monitor and adjust performance to keep the engine running at its best. That means less wasted energy and better results during long journeys. But the surprising detail is its flexibility. The Wärtsilä 31 can be adapted to work with different fuel options, making it easier for ships to prepare for future changes in the maritime industry. It shows that the future of giant machines is not only about becoming bigger. Sometimes, the real innovation is making every drop of fuel count. This engine represents the final evolution of the giants that move the world's largest container ships. At first glance, it looks like a giant piece of industrial machinery, but its job is incredibly simple. Transform controlled explosions into movement powerful enough to push a floating city through the ocean. The MAN B&W G95 MEC10 is a low-speed two-stroke engine designed to deliver enormous torque directly to a ship's propeller. That means fewer energy losses and maximum efficiency. Instead of using complicated systems to transfer power, this engine connects its massive force almost directly to the shaft that turns the vessel forward. The result is a machine capable of moving thousands of containers across the planet. But perhaps the most impressive part is that this technology represents decades of evolution, where engineers turned enormous engines into reliable, efficient giants. And without machines like this, global trade as we know it would simply stop. If you enjoyed discovering the incredible machines that power the biggest ships on Earth, make sure to subscribe to the channel. Every week we explore the most powerful, unusual, and fascinating machines ever created. Turn on notifications so you don't miss the next journey into the technology behind the giants that shape our world.